So our first type of question that we want to look at for our review is actually not on the review sheet in the packet, but knowing, actually it is. Maybe it's after this. We'll see. We'll see if it comes up after this, otherwise I'll just insert a blank slide here. So the first thing here is the properties, knowing what the properties say. The associative property is our grouping property, where we can put the parentheses in different places and it still means the same thing. The commutative property is like our morning commute, that we drive to work and then we drive back from work, and it's the same thing both ways. The identity property is what we do to keep something the same. So by adding 0 or multiplying by 1, it does not change a number's value. The inverse property is what we do to a number to get that identity value. The distributive property is passing out through a set of parentheses. Remember when you name them that you need to include the of addition or of multiplication as well as the actual name of the property. So, identifying these properties, 5 plus 0 equals 5. What is that?
Identity.
That's the identity. And then we need to make sure to also say of addition. What happens in the next one? It's the associative. The parentheses moved around. Remember, the associative is like who you associate with. So these numbers are reassociating themselves or regrouping themselves, but that's an okay thing to do. So this is the associative of addition. Then your review sheet says, and another one, just to let you know, you'll have 3 questions on properties. Okay? Questions on that? Okay, here's the thing that is not on your review sheet, but is something that you should be able to do. And that is knowing how to classify real numbers. So these are our number classes. At this point, if I ask you a number, it's going to be a real number, because we have not studied any non-real numbers together yet. A whole number begins counting at 0 and counts up, so there are no negatives, and it's just counting numbers, so there are also no decimals or fractions. An integer is like the whole numbers, but it can also include negatives, still no decimals or fractions. Rational means that it could be written as a fraction. Irrational means it cannot be written as a fraction. So our irrational numbers are typically like pi or special numbers like that, or ugly square roots like square root of 2. Okay? So on your test, I will give you a number and say, where does it belong? So for example, if I gave you 7, we want to say, in which ones of these does it belong? And it's going to belong in more than one. So we want to give all of the possibilities. So is 7 a real number?
Yeah.
Is it a whole number?
Yep.
Is it an integer?
Yep.
Is it rational?
Yes.
Then it can't be irrational because those are opposites. Okay? So every number is either going to be rational or it's going to be irrational. It can't be both of them. Okay? Let's try another one. Let's say -2. Is it real?
Yes.
Is it whole?
No.
No, because the whole numbers can't be negatives. Is it an integer?
Yes.
Is it rational? Yeah, it's not a decimal that goes on forever. Okay.
Like 1.66 is irrational.
1.6 repeating, so if it's 1.6666 forever, that actually is still rational because that's the same thing as 1 2/3, which is 5/3. So that's actually rational. When I say it's a decimal that goes on forever, it has to also not repeat itself. So like pi, 3.14159 and blah, blah, blah forever, and it never starts to have a pattern of repeats. So that's an irrational number. So pi is irrational, or like square root of 2, or square root of 5. Any of those square roots that don't work out evenly are irrational numbers. Okay? Questions on that? Okay, then being able to find solutions to these, we need to turn our words into symbols and solve the problem. So difference, what does the word difference mean? Subtraction. So I'm going to do 36 minus 3, and get -39. What does quotient mean? Divide. And what's the number? It didn't for some reason go on the slide.
-1/2.
Negative half.
So it's
So 12 divided by -1/2. How do I divide by a fraction?
multiplied by the reciprocal.
Multiply by the reciprocal. So this is 12 times -2/1, which gives -24. Other important arithmetic words are sum. What does sum mean? Addition. And product. Multiplication. Okay, so any of those could come up on the test where you would need to know what those 4 words mean and then solve the problem. You don't have to show work on your test. If you give me a right answer and there's no work, I will still give you the credit for that right answer. But if you give me a wrong answer and the problem is worth more than 1 point, you're losing everything because I don't know where you went wrong on it. So for example, if on this first one, I could see that you knew you were supposed to do 36 or -36 minus 3, but then for some reason you put -33 instead, but you had written out what you were trying to do, you'll only lose part of your credit then, because I'll know you knew what difference meant, but you did some arithmetic wrong. Okay? As opposed to if all I see is a wrong answer, you're losing everything the problem is worth. Okay? Questions on this type of problem? Evaluating the expression has a hidden direction there of using the order of operations. We always use the order of operations, but that's the specific goal of these problems here, or do we know our order of operations? So our order of operations, parentheses, exponents, multiply and divide, which is 1 step altogether, and then add and subtract, which is 1 step together. So make sure you know your order of operations. For the first one, there are no parentheses, there are no exponents, so then we begin with the multiplication, and then we do our addition and subtraction in the order they come in the question. In the second one, we have some parentheses. We have some exponents. Then we want to multiply and divide in the order they come in the problem. So I've got this -49, there's nothing there. But then I've got a -4 times a -5 makes -20. And then I want to divide. And then I'll add and subtract anything that's left over. This is another case where showing work. I can see you were trying to do the steps in the right order, but instead of saying 4 times 5 is 20, you put 25 or something like that. And I'll know you knew your order of operations, you were trying to apply them correctly, and it was just arithmetic that went wrong. So you wouldn't lose all your credit here. Okay. Questions? Evaluating when we're given certain variable values, we want to plug in what those variables are. It is important to plug them in parentheses. Sometimes it makes a difference, sometimes it doesn't, but it's better to be safe than sorry. So I'm going to plug in a 4 for x, and I'm going to plug in a 32 for y, and then evaluate using our order of operations. So I get 8 minus 128. Which gives me -120. For the next one, I want to plug in a -1 for x and a +3 for y. So order of operations, parentheses, but we don't have anything going on inside of the parentheses. All these parentheses just mean multiplication. So then exponents, so taking care of that exponent, what is -1 squared?
1.
+1. And this is where those parentheses can really make a difference. If we didn't put parentheses around that, you might say that it would actually only be a -1. But since we're squaring the whole thing, we need to make sure that it is a +1. Then we do our multiplications, and I get +12 and +2. Add them up, and we get 14. Questions? Simplifying, we want to combine any like terms that are present in the problem. Remember, like term means two things about it: same letter and same power. So x's and y's are different, x's and x squareds are different. So in this first one, if I look for x's, I've got a 4x, a negative 2x, and a positive x. Remember, signs attach themselves to the number that follows it, so that's a negative 2x. So I'm going to do a 4x plus negative 2x plus 1x gives me 3x's. And then our y's, we have 3y and 5y makes 8y. Can't put those together because x's and y's are different. What do I need to do first in this next one? Distribute. So I'm going to take the 3 and pass it out. Gives me 3x squared minus 6x. We need to distribute again, but being careful that we attach a negative to the number that follows it. So we're going to pass out a negative 5, not just a 5. So it gives me negative 10x squared plus 5x. Okay, attach a negative to the number that follows it. Now combining like terms, we can look at our squares and get negative 7x squareds, and look at our plain x's and get negative 1x, or just negative x. If you write the 1 in there, that's totally fine. I wouldn't take off any credit for calling it a negative 1x. That's what it really is. Questions? Okay, solving linear equations. Our first step is to get the variable part alone. So I'm going to add 13 to both sides. And then to get the variable itself alone, undoing what's being done, it's being multiplied by 5, so I'm going to divide by 5. Remember that in an equation, you can always check your answer. So when you hand in your test, you can know whether you got these equation questions right or wrong. Hopefully, if you got it wrong, you can go back and figure out what you did wrong and fix it. But you can always check your answer by taking it and plugging it back into the equation and making sure that it results in a true statement. For this next one with the fractions, we have two options. We can either just do it with the fractions and handle them and work through with them, and if you don't mind fractions, that's a fine thing to do. And this one actually isn't so bad to do because the denominators work out nicely. Or, if you don't like fractions, you can get rid of them by multiplying the entire equation by something that will cancel them out. So what can I multiply this by? 6. So if I multiply 1/2 times 6, that makes 3. 2/3 of 6 is 4. Negative 1/2 of 6 is negative 3. And negative 1/3 of 6 is negative 2. And then you don't have any fractions to work with. So then I want to get all of my a's together on one side. I'm going to do that by adding 3a. Gives me 6a plus 4 is negative 2. Be careful those little negatives. They like to disappear in a problem. So be careful of your work there. Subtracting 4 from both sides gives 6a is negative 6. Dividing by 6 then gives a is negative 1. Okay. And I could check that by taking it back to the original problem and plugging it in and making sure it results in a true statement. Questions? As we get into solving these equations, showing work is a really good idea. You know, a lot of people just like to do it all in their head. But if something goes wrong, you're losing all the points, and a problem like this could be worth 3 or 4 points. So it'd be much better to lose 1/2 of a point than to lose 4 points. In the first equation here, I need to get rid of the parentheses as my first step, so I'm going to distribute this negative 1.1 through. So I get negative 1.1x minus 3.3. Then I'm going to get the part with the x in it alone by adding 3.3. And then I want to get the x alone by undoing the negative 1.1 by dividing by it. Which gives me 8.
Wouldn't it be negative 8?
It would be, thank you. Like I said, those negatives love to disappear, at least for me. For the next one, again, we have some parentheses, so we'll start out the problem by getting rid of those, distributing the 3 and distributing the 8. You only distribute to the edge of a parentheses, though, so I don't distribute to the 5 because it wasn't a part of the group. Then over on that right-hand side, I have some things that can be combined. I can put together the negative 8 and the 5 to make a negative 3. Then I want to start getting stuff all together on one side or the other. I'm going to do that by subtracting 3x. Lots of other things you could do, but that's how I'm going to start. Then adding the 3 to get the x part alone. And then dividing by the 5. It doesn't divide evenly, so what I would do is just leave it what it is. That's a fine answer just by itself. 9 over 5 is a good, valid answer. You could turn it into 1 4/5, or you could turn it into 1.8, and those are all acceptable answers. But they all require more work when I could just leave it right here and be done. Questions on solving these linear equations? Okay, so then we have some absolute value equations here. An absolute value equation has two solutions. This is what we learned in our last lesson. We solve them by setting the inside equal to the positive and setting the inside equal to the negative and solving the two equations individually. So in the first one, subtracting 5 gives 4. And the second one, subtracting 5 gives negative 14. So both of those are answers or solutions to the equation. For the second one, set the inside equal to 13, and then set the inside equal to negative 13. In the first one, subtract 4 gives 9, and divide by 3 gives 3. In the second one, subtract 4 gives negative 17. And dividing doesn't go in evenly, so that's where I would just leave it as a fraction, which is a fine answer. But you could also turn it into negative 5 2/3. I would prefer not the decimal here because it's a repeating decimal, so fractions are really better in that case. Questions? And these ones were asked to solve for a particular variable, and there's more than one variable in the problem. So to get y alone, I need to undo what's being done to it. It has a 3x added to it, so I'm going to subtract 3x from both sides. When y is alone, it is done. In the second one, I'm trying to get the y part alone, so that means I need to get rid of the 9x first. So I subtract on both sides. I'm trying to get the y alone. So it's being multiplied by a -2, so I need to divide every single term by -2. Each time you hit an equals, a plus, or a minus, do another division. So I get y equals -3/2 and positive 9/2 times x. Negative divided by negative is positive. Question? In the first one here, we have to get rid of those parentheses. I'm going to distribute through. 10x plus 5y is 10. And now this looks like one that we already did. So we need to get the y part alone by subtracting 10x. Biggest mistake that students make here is trying to combine the 10 and the -10. Okay? One of them has an x, one of them doesn't have an x, so they are different types of things. So we need to just keep them as two separate terms. Then divide by 5 to every single term. We get y equals 2 minus 2x. For the next one, you have some options. You could multiply the whole equation to get rid of fractions. If you wanted to do that, that would be a fine thing to do, or you could just work it through with the fractions. If you want to multiply, we would be multiplying by 15. So that would give me 5x minus 6y equals 15, making sure that you multiply the whole equation by the 15. It is a pretty common mistake for students to forget to multiply that little 1 over on the other side, because it's not a fraction and it's all by itself, so we just kind of overlook it, but you have to multiply every single term in the problem by the 15. Okay. Now this looks exactly like the last one ended up, so I'm not going to finish this one on through. Questions? On your test, you would need to finish it on through. You need to get this to a y equals answer. But just for time, we'll let it go here. Inequalities. To solve an inequality, we can treat it like an equation, except watching out for multiplying or dividing by a negative. So I'm going to begin by subtracting 3. And then dividing by 2, since that's a positive 2 that I'm dividing by, I don't have any problems. And I get x is less than or equal to 3. In the graph, an equal to bar means a closed dot because it can actually be 3, and then anything smaller than 3 is okay as well. In the next one, begin by getting rid of your parentheses, distributing the 3. Get all of your variables together on either side, and this is a preference thing. If you want to always move them over to the left-hand side, the arrow will point you in the direction that you're going to need to shade on your graph. If you want to move them so that your variables are positive, you won't have to worry about dividing by a negative and flipping your sign. So that's the way I like to do it because I lose negatives. And I'm going to add 6. And then I'm going to divide by 7. It doesn't divide evenly, so I'm just going to leave it at 12/7 is greater than x. That is the same thing as x is less than 12/7. We can turn it around and read it in the other direction, just making sure that the alligator mouth is still open to the same thing. Okay? So either way, it's trying to eat the 12/7. On the graph, this would get an open circle because it can't actually be 12/7. It can get really close and be anything smaller. Questions? I'm going to skip these two on how to solve the compounds because the next ones with absolute values will end up turning into compounds. So we'll look at that skill on these questions. So when we have an absolute value inequality, we need to turn it into a compound inequality in one of two ways. A greater than is going to separate to be two separate inequalities. The first one exactly as is, and then or, for the second one we made two changes, flip the sign, make the value negative. Solve them individually, subtracting 2 in the first one and subtracting 2 in the second one. Both parts are your solution and should be graphed on the number line. Close circle on the 1, and x is bigger than that, so it goes to the right. Close circle on -5, and x is smaller, so it goes to the left. And we end up with that empty middle on an or statement. Remember, an absolute value means distance from 0. So this original question is saying some distance from 0 needs to be further away than 3 units. So if I'm trying to be further away from 0, I should be shading away from that 0. For the second one, it's a less than. A less than is going to make an and statement. So we take the opposite of the value and put it over on the left, and then string the whole thing together in one piece. Again, thinking about absolute values meaning distance from 0, this says that I want a distance to be closer in than 7 units away. So we want to keep this one together. To solve, I'm going to subtract 2 from all 3 parts when you have an and inequality. Whatever you do to one part, do to all parts. And then I need to divide by -3 to all 3 parts. And this is where I need to be careful. I just divided by a -3. Dividing by a negative has to flip around those inequality symbols. So I do everything I can to avoid it in a problem, but sometimes it just happens. So make sure that you know if you multiply or divide by a negative, you end up having to flip that sign. You get a +3, x, and a -5/3. On our graph then, we'd want -5/3, 0, and 3. Close circles on each of them and shade between them. Questions on those? Couple word problems to go. We're given a formula. It says solve the formula for h. I would stop here and actually do that. Otherwise, it is likely you will forget to do it, and then you'll only give me part of your answer. So if my formula is a is 1/2 bh, and I want to get h alone, I have to undo the 1/2. 1/2 is being multiplied on both sides, so I can multiply by the reciprocal on both sides to cancel it. So I get 2a is bh. I'm trying to get h alone. I can divide by b. Then I'll keep reading. I think yours says what is the base, but it should say what is the height. I think that's why mine is all capitalized so that you recognize that change there. So what is the height of a triangle with an area of 10 square inches? So A is 10, and a base of 5 inches. So I can plug those into our formula now and get 20 over 5 is 4 inches. Questions? Yes.
Can you take points off if you don't have the inches?
The unit, no, I won't take off points without it. Unless it like specifically says using appropriate units, what is, and then you should make sure you have them, but this one didn't really specify. You played 6 rounds of golf last week. In relationship to par, here were your scores. Add these numbers to see what your score was. Don't make this problem harder than it is. It just told you to add up the numbers. That's all it told you to do. So -2 plus 3 minus 0 plus 5 minus 3 minus 1. And what did we score for the week?
+2.
Okay, so we ended up scoring 2 over par. That's it. That's all it asks you to do is add them up. So don't make it harder than it has to be. Okay? Some of you may be very good at guessing and checking. I am not gifted in a guess and check area. I can guess and check forever and seem to never stumble upon the right answer. So some of you may be able to read this and just figure out what it is. If you can, good for you. I can't. So what I need to do is turn these words into math symbols. 6 more than. How do we say 6 more than in math?
6.
6 plus something. 6 more than 3 times a number. How do I say that?
3x.
3n, 3x, 3 whatever letter I like. Is equal to
And
the number n. Now I have an equation and I can solve it. Subtract 3n from both sides and divide by -2. I get -3 is n. I will not penalize you for solving this by guess and check. If you have the answer -3 there and there's little to no work shown of your guess and check, I'm going to assume that you were able to stumble upon that answer on your own. But that's something that I am not really good at doing. Okay? Questions?
Can you use our calculator on top?
Yes, I will not take away your calculators. Except for at most point this year.
put it down, check.